Hello everyone, welcome back to a new video. In this video, I'll be showcasing what I've been implementing and working on in this Vulkan toy renderer um, that I've been working on. Yeah, anyways, I got hardware ray traced shadows working. So these are using the Vulkan ray tracing API. It's using hardware ray tracing hardware to accelerate ray tracing the BHV. It's very nice. These are very crisp shadows. Of course, these are dynamic. If I change the sun angle, these change. These are not bound to any resolution other than the screen resolution, of course. I also implemented these shadows for lights. So I have a point light right in front of the camera, so it follows where I'm looking at. And it also has these shadows, and this gives a very nice effect when you bring it close to geometry. For example, if I zoom in to this, you see how these shadows are very, very crisp, and these are pixel perfect shadows. Obviously, most lights are not uh, infinitely small point lights. Like for example, the sun, it's actually a circle, so the shadows that it casts wouldn't be perfect. They would be blurry as the shadow gets elongated. But of course, I'm only using one shadow ray per pixel, so yeah, this is all I can do. Of course, you can up that and use some randomization to give the effect of soft shadows, but that simply takes too much of a performance hit. So I did not do that. So yeah, this model right here, it's from Polyhaven. Same thing for this rock model, and the rest are models that I made myself. These are just simple models. The textures are also from the textures are from TextureCan. These are PBR textures. Right now, I'm only showing the albedo, color, roughness, and metallic, but I can enable normal maps. And as you can see, just very nice pixelated normal maps. Same thing for, oh, sorry, not that. Yeah, there you go. Enables or disables normal maps. I can also disable or enable flat shaded, the flat shaded look, like that. Yeah, so if you look at the bottom left, I just have some bitwise toggles I can use for this. So that disables or enables flat shading, and that disables or enables normal maps. Yeah, very, very simple. Yeah, let me bring the sun down so you can see the shadow mapping, or it's actually not shadow mapping, it's the shadow ray tracing that's occurring. And I implemented this because I was too lazy to implement shadow mapping. I was thinking to myself, instead of doing all of that depth texture stuff, I could just implement ray tracing and be done with it. And it seems to work very, very pretty nicely. So you have this rock, I'll bring the light close to it, see how it casts a very nice shadow. Same thing for this rock ingot and this thing over here. Yeah. And this works well as well with cloud shadows. So if I bring the sun over there, yeah, see these corners, the clouds are sweeping over, and these are being accounted for when calculating the shadow map, or the pixel shadow, not shadow map. Yeah, these are pretty nice. I also implemented reflections. So if I have this toggle over here, I enable it, and it enables these mirror reflections. As you can see, there are some artifacts. I think I'm missing a non-uniform indexing call somewhere in my code, but I haven't figured that out yet. But for now, it looks like it works. So I'm just gonna either assume that it's a fault on my part, it's a fault of the Slang compiler, because actually there's a bug where the Slang compiler gets rid of non-uniform indexing calls for some reason. It's been fixed. It's been merged into master 2 days ago. But of course, I need to wait until the Vulkan SDK ships that new version of the Slang compiler. See, or maybe it's a driver issue. I am on an AMD card, and those are well known to not have very nice ray tracing drivers, especially on Windows, and especially I'm using integrated graphics. So the fact that it supports ray tracing to even begin with is actually pretty impressive. So yeah, there are three points of failure, and I have no idea which one it is. But anyways, so yeah, these are mirror perfect reflections. As you can see, you can see the reflection of this rock thing within this metallic sphere. If I enable the flat shaded look and normal map, you can see it's very interesting. I'll tell you that much. Of course, you have this plane looking thing that reflects everything that's off of it. Of course, I'm using only one ray tracing ray per pixel, so all you can get is mirror-like reflections. If you wanted to get rough or glossy reflections, you'd need to use multiple samples and perturb them a little and denoise them. But for now, this works. I'm just going to assume that every surface is a mirror. And yeah, it's very nice. This also works for these copper pipes. This light is really annoying me, but I don't have actually I do have a toggle. I can just disable that in my code. Extra lights enabled. I'm just gonna recompile the project with that light disabled. It's just annoying. And yeah, it's very interesting. So just let that start the program. All right, there we go. All right, we're back here. There we go. We don't have the point light following us anymore. So yeah, you see these copper pipes. So far, I'm only the recursion depth for these reflections is only 2 so far. So as you can see, I have this mirror reflection over here, and within it there should be a reflection. Hold up, if I can get a good angle of that. Right. I don't think you can see it well here, but here you probably can. Yeah, there we go. See? All right, so I have the ball right here, and if I look into this mirror, you can see that it reflects the reflection of the thing that's being reflected. Yep, that's just recursion depth of 2. This is implemented using ray queries. It's not implemented using ray pipelines. I'm just doing some function calls to solve the ray tracing recursion at compile time, because the Slang compiler can solve that at compile time. Yeah, you have this rock. Wow, that's very shiny. Hold up, let me do that. You have this rock. If you look right into here, the frame timings, go to hell, because of course that's not very great for the GPU, because there's a bunch of divergent rays, a bunch of divergent warps. Not very great. Yeah, it's interesting. Not that much. And you could just disable or enable it. As you can see, the frame timing, it's taking a big hit from this. So like if I take a nice shot, you see right now it's at 7 milliseconds per frame on the bottom left. If I enable ray tracing, 16. That's more than double. I am running at 1440p, of course. So that is a lot of pixels. That's that are being very, very slow. But yeah, I think it's interesting. Of course, I can spawn more of these spheres. If I enable it, you can see that the spheres that I just spawned are visible within other spheres. If I get the smooth normals mode on, you can see that's just a perfect mirror. Yeah, it's very, very nice. Even though, yeah, as I said, all reflections are perfect mirrors. So even this rock material, which is supposed to be very, very rough, it's very, very reflective, which is of course not what is supposed to happen. But of course, to get rough reflections, you either need to approximate it using cone tracing or blurring, but or you could do it the path tracing way, where you just create multiple samples, disturb them, and denoise the image. But that will look very ugly, and it would be very performance intensive. So I'm gonna need to figure out a way to get a nice approximation that does not hurt performance that much. Same thing for shadows. I suppose there is a way to get soft shadows without needing to do multiple samples per pixel. But yeah, it's a very, very interesting thing. Yeah. Spawn a lot of these. Oh, wait, let's not go into cloud. Yeah, you see the shadowing. If I recall, okay, I guess I went over. And there should not be a limit to. Oh, okay, that's not going to be a very good example. A limit to the yeah, to the max distance the shadow ray can hit. It's very very interesting, yeah. Oh yeah, that's wow, so shiny. Of course, buggy because as you can see, there's the blocky artifacting. Okay, anyways, goodbye.